we're going to be focusing on how to solve radical equations. Now that we understand that a radical equation is one that has a variable underneath the radical sign, now we can focus on how we're going to solve them. So, our first step is to isolate the radical, and in this case, the radical's already isolated. When the radical is on the side by itself with nothing else being added, subtracted, multiplied to it, then it has been isolated. So number one, check, we have isolated the radical. Number two, we're going to raise each side of the equation to the same power so that we can eliminate that radical. So what you're going to have to do is think about what index this radical currently has. So if I think about the index of this radical, it's not shown, so that must mean it's a square root. So now I'm going to take each side and I'm going to square each side of this equation. Remember, what I do to one side, I have to do to the other side. That gives me an equation that looks like x squared on the left side, and on the right side, the square rooting and the squaring are going to undo each other. Remember, that's why we did it. So what's left is everything underneath that radical. So the radicand is what is left when we take it to the power of the index. Now, number one, we have isolated the radical. Number two, we have raised each side of the radical. Now look what happened. You have eliminated that radical sign. And finally, we're going to solve that resulting equation. So now, this is a quadratic equation, so I'm going to get it equal to 0. I'm going to add 4x to both sides, and I'm going to subtract 5 from both sides, and I can find out now that I have x squared plus 4x minus 5. It looks like it's going to be very easily factorable, so I think about the numbers that are going to multiply to negative 5, but add the positive 4. That should be a positive 5 and a minus 1. So since the a value is 1, I can go straight to saying x plus 5 and x minus 1 are going to be my two factors for this. Now using the zero product property, I can try to make this factor equal to 0, or I can try to make this factor equal to 0. Either one is going to make the statement true. So now I get x is equal to negative 5, because that would turn this factor to 0, or x is equal to positive 1. That would make this factor turn to 0. So now, well, we have to check our solutions. Well, okay, let's go through that very quickly. I love working with the number 1 because it's super easy for me to use. So I'm going to check x is equal to 1 first. Now when I plug in 1, remember that I'm going to be using the original equation here. So I'm going to be using x is equal to the square root of 5 minus 4x. Make sure you're looking at the original equation when you're checking these things. So I put in the number 1, and it's equal to the square root of 5 minus 4 times 1. And then I get 1 is equal to the square root of, well, 5 minus 4 is 1, so this is, hey, woohoo, that checks out. 1 equals 1, this is definitely a solution to this problem. Let's go try the other one now. Let's see what happens when I want to check when x is equal to negative 5. So I substitute negative 5 into the equation in both places of x, and I can see that negative 5 times negative 4 is going to equal 20, and that's a positive 20, so positive 20 plus 5 is 25, and the square root of, wait a minute, the square root of 25 is positive 5, but negative 5 doesn't equal positive 5, and because it doesn't equal, this is not a solution to our problem. This is what we're going to call an extraneous solution. And an extraneous solution is an apparent solution. It looks like it should work. We've done everything correctly, but when we put it into the original equation, it does not satisfy the equation. So we only have one solution to this equation, and that equation is x equals 1.